revise. The first question 1. Okay, are you ready? Let's proceed. Question 1. The water flow through a horizontal pipe as presented in figure 1 at the rate of 1 gallon per second. The pipe consists of two sections of diameter 4 inch and 2 inch with a smooth reducing section. The pressure difference between two pipe sections is measured by a mercury manometer. Neglect frictional effect. Determine the differential height of mercury between the two pipe sections. Alright. The first, you can see we have to analyze the situation. As you can see, we have the flow from left to right. Alright. So this is the analysis. Number 1, we can apply Bernoulli equation. And then you can see there is the pressure difference for manometer. So we can use manometer reading. So by using hydrostatic equation, which is P2 minus P1 equal to negative rho G Z2 minus Z1, we can calculate the manometer reading. As well as for the Bernoulli equation, we can apply P1 at gamma plus V1 squared over 2G plus Z1 equal to P2 over gamma plus V2 squared over 2G plus Z2. This is between 2 points. So let's start with the Bernoulli equation. We focus on this one first, alright? So I want to focus on the flow from left to right. I must take 1 point. Let's say this is point number 1. And the point shall be on top of the mercury tube. This is on top. Okay, this is 1. And then this is 2. Okay, so from here, I need to investigate the pressure difference. Alright. So let's begin with the Bernoulli equation at point 1 and point 2. This is the imperial unit using inch, alright? So the first, we can start with the Bernoulli equation. Apply Bernoulli equation at point 1 and point 2. So P1 over gamma plus V1 squared over 2G plus Z1 equal to P2 over gamma plus V2 squared over 2G plus Z2. Remember that the Bernoulli equation only apply at the steady flow region. It cannot be applied at the boundary layer or at the weak region. Secondly, can be applied at under incompressible liquid. Alright. So from the Bernoulli equation, what can you reduce? What can you cancel? Of course, you can see the elevation is the same, right? So now you must set the reference line. Let's say I want to set my reference line at here. Okay, this is my reference line. Reference, okay, line. So that means the elevation is the same. Why don't I cancel? I cancel out, cancel out. So what should I get here? I should get, basically I can get the P2, this one move to the other side and then this one go to the left, right? So P2 minus P1 over gamma equal to V1 minus V2 squared over 2G. We know for sure gamma is a rho multiplied by gravity. So this one, we go to the other side. P2 minus P1 equal to rho gravity V1 squared V2 squared over 2G. We can cancel gravity. We'll have a density only. So density of water, not density of mercury. We are dealing with water. Density of water over 2 V1 minus V2 squared. So let's say this is equation 1. And then apply manometer reading. At, manometer reading. So I should relate point 1 and point 2 as well. So let's say this is point 1 and this is at point 3 and this is at point 4. So I want to start the calculation from 1, go to 3 and finally go to 2. So 1 go to 3. So P1 minus P3 or P3 minus P1? Do you still remember? P3 minus P1. Perfect. Negative rho gravity. Rho of what? Rho of mercury or rho of... This is mercury, yeah? And then the density of mercury, basically, I think it is given. It is 847. Okay. Density of water, it is 62.4. Okay, you can look at table. Don't worry. Alright, density of what this one? P3 go to P1 go to P3. What the fluid involved? Fluid of mercury or fluid of water?
Water.
Yes, perfect. Z3 minus Z1. Okay. So now we go to P. P3 is the same here. We can skip, we can jump. So P3 go to P4. So P4 minus P3 equal to negative rho of mercury now because we are dealing with mercury measurement. Z4 minus Z3. And then from 4 go to 2. So P2 minus P4 equal to rho of water gravity Z2 minus Z4. Okay. So we have Z1, Z2, Z1, 2, 3 and 4. So let's define here clearly. What is Z1? Z1 equal to what? Any ideas, class? How to get Z1? How to get Z1? Okay. If you don't know how to get Z1, let's consider from this level to this level as X. So in order to get Z1 from the reference line, which is H plus X. X2, Z2, how to get Z2? Z2 is also the same, H plus X. Okay, Z3 and Z4. Okay, Z3 is equal to 0. Z4 is equal to H. Clear? This is at point 4. So Z4 equal to H lah. And Z3, this is Z3. Z3 at the reference line. So should we substitute? Yes, we can substitute. I want to substitute. Okay, equal to negative rho of water gravity. Z3, where is Z3? Which is 0 minus Z1, which is H plus X. Negative mercury, which is Z4 is H minus Z3, which is 0. Rho of water, Z2 is H plus X and Z4 is minus H. Okay. So can we simplify further? We can get negative cancel. We get rho water gravity H plus rho water gravity X. Negative rho mercury gravity H. Negative rho water gravity H minus rho water gravity. Okay, this is cancel lah ya. No need to expand. You will get negative rho water gravity X. Okay, so I plus everything. Okay, plus. You can get P3 cancel. P3, P4, P4. You will have P2 minus P1 equal to this one. You will have cancel with this one. You only have rho of you will only have the G H rho of water minus rho of mercury. Okay, quite easy. This one assume as equation number 2. So equate back equation 1 and equation 2. Okay, because both the same subject, P minus 2, P2 minus P1, P2 minus P1, right? So, rho of water over 2, V1 squared minus V2 squared equal to GH, rho of water, rho of mercury. So, from here, I need to find V1. Velocity at 1, use the flow rate, Q equal to AV. So in order to get the V1 is a Q over area 1. In order to get V2, Q over A2. So Q is the same, gallon. Alright, I convert into feet cube per second. 1 gallon is equivalent to 0.13368 cubic feet. Okay, because all this in the feet cube. So I need to find the V1, which is 1 gallon per second divided with area, which is the area here. Okay, which is, you can see it is circular. So pi over 4 diameter in the feet. The diameter is 4 inch. And this diameter is 2 inch. Alright, so just include here 4 inch divided with 12 foot in order to convert into foot. Okay, 1 foot 12 inch squared. You will get the answer to be 1.53 foot per second. And V2, sorry. This one, you must multiply. Okay, this one with 1 gallon, you need to convert lah. Alright, because I want cubic feet per second. Okay, 1 gallon equivalent to 0.13368 feet cube. You will have the answer 1.53 foot per second. V2 equal to 1 gallon per second divided with pi over 4d squared. Alright, diameter is 2 inch, right? Okay, my diameter now is 2 inch. So convert into feet, divide by 12. 2 divided with 12 squared, multiply with conversion of gallon. 0.13368 feet cubic. You will have 6.13 feet per second. Alright. So just substitute the value of V1 and V2. Okay. And then make the H become the subject. So now H equal to root of this one, V1 minus V2 squared, divide with 2G, root of water, root of mercury. So this one go to the denominator, you will divide all with density of water, V1 squared minus V2 squared over 2G, 1 minus ratio of mercury with water. Okay, velocity 1, you will get 1.53 squared minus 6.13 squared over with 2 gravity 32.2 divide with 1 minus density of mercury over water. Finally, you will get the final answer 0.0435 feet. Okay, convert into inch, divide, multiply with 12, you will get 0.522 inch. Okay, any question, class? Okay. And then, can you repeat?
I'd like to ask, can you show again how to get Z3 equal to 0?
Which one is Z4?
Z3.
Which one is that?
Z3.
Okay, Z3 equal to 0 because as I set as a reference line. Okay, you can set at P4 equal to reference line also can, no problem. But I choose the lowest one. The lowest one as a reference line. When it is under reference line, it is automatically 0. We start from 0.
Oh, okay.
Clear, yeah, Nasrul?
Clear, okay. Thank you.
Okay, we go to example 3, question 3. A siphon water pump as shown in figure 3 is used to pump water from a large reservoir to a lower tank that is initially emptied. Right? Water leave the tank through the orifice. Determine the height h the water will rise in the tank at the equilibrium and assume that water velocity V2 equal to V4. Alright? So this is orifice. Orifice is like a nozzle. Alright? The water flow out. So assume V2 equal to V4. This is the hint. So what should I do? First, I try to use the Bernoulli equation because we are dealing with first incompressible. Second one, this is the flow. Alright. So I need to find V2 first. How to get V2? Okay, I can use Bernoulli equation at point 1 and point 2. So apply. Bernoulli equation at point 1 and point 2. Alright, so P1 over gamma plus V1 squared over 2G plus Z1 equal to P2 over gamma plus V2 squared over 2G plus Z2. So now, okay, we can see that we can set this one as a reference line. So that means Z2 automatically equal to 0. So Z2 cancel 0. P1, okay, this is at this level. So definitely P1 is P80M. Automatically equal to 0. Cancel. And then velocity is equal to 0 because this is reservoir. It is hardly to see the movement of water at the surface. Okay, it is nearly 0. So velocity equal to 0, velocity 1. So we have, okay. So try to make V1 as the subject. So this one go there. You will have V2 squared over 2G equal to Z, alright, minus P2 over gamma. Gamma is rho G lah, okay, rho gravity. So you know that the water at this level, for example, this is at point 2. How to get pressure at point 2? Definitely you have height of water. So pressure at point 2 is rho G H, right? Okay, the H is given, H only. So why don't you substitute P2 equal to rho of water gravity H. I want to substitute, okay, I will get rho of water gravity cancel with rho of water gravity. So I will have Z minus with H. Then I will get the V2 equal to square root 2G Z minus H. This is equation 1. Alright. After that, I need to find velocity at 4. This one achieved. So I need to find V4 first. So I can use the correlation V4 with V3. So apply Bernoulli equation at point 3 and 4. So again, write again P1 over gamma plus V1 squared over 2G. Sorry, this is not 1 anymore. Okay, this is 3. And Z3 equal to P4 over gamma plus V4 squared over 2G plus Z4. Okay, we notice that at P2, sorry, at Z3, okay, at 4, you can see the point 2 and 4 almost the same. So the Z4 is here, okay, is equal to 0. It is at the reference line. So Z4 cancel. Pressure at the out of orifice because this point exposed to the atmosphere, alright, atmospheric pressure. So P4 equal to 0 because it is P80M. Anything that exposed with the air under P80M is equal to 0 when it is gauge pressure. So P4 cancel. And then P3, can you see? It is also at the top of the surface. Alright. So it is cancelled. And velocity, you can see velocity at 3. At this point lah, the velocity to increase of water is nearly 0 because it is hard to see the velocity on the surface move. Okay, it is almost 0. So what do we have now? We only have V4 squared over 2G equal to Z3. So what is our Z3? Our Z3 is H, right? Our Z3 is H now. So we can replace with H. So V4 equal to 2GH square root. Okay, let's say this is equation 2. It is given that V2 equal to V4. Okay. So equate them. V2 equal to V4. So V2 is square root 2G Z minus H. And then V4 is 2GH. Square root, squared both sides. You will have 2G Z minus H. 2GH. Cancel 2G. You will have Z minus H equal to H. Thus, H is equal to Z over 2. Alright. This is Z for what? Okay, can you see this is Z minus H. Which H and Z? This is comparison with Z1, right? Okay, this is 1. This is 1. So, Z1 over 2. Where is Z1? This is Z1. From the reference line to the top of 1, Z1 equal to 15. Thus, 15 divided by 2 is 7.5 feet. Okay, any question? Okay, any question, class? Is it clear? Do you understand?
Betul. Zoom out sikit tu.
Which one? This one?
Saya nak salin. Terlalu pantas.
Tapi macam mana? Faham tak? Kelas, do you understand the concept semua? Just compare je. You compare point 1 and 2, cari velocity, got the velocity. Compare 3 and 4, find the velocity at 4 and equate them together, you will find H. Okay.
Boleh tak?
Okay, Faizal, do you have any question?
Zoom in.
Zoom
yang
in yang
equation
mana? Which one?
sekali yang V2 equal V4. Okay,
This
okay
one.
doktor. Okay, terima kasih doktor.
Okay. Have you done copy? Have you done your writing? Do you have any question? Do you understand? Aisyah, Alia Maisarah, any question from your side?
No, doctor.
Okay. Okay, let's proceed on the lecture, this one. Integral form. Do you still remember the integral form? The reason why we use integral form, because we want to convert from system to control volume, right? So this chapter I'm going to cover example 2. The pipe flow, okay, let me zoom lah ya. The pipe flow fill the cylinder tank. Okay, that means it flow from left to right. The water depth in the tank is initially 30 centimeter. Okay, that means initially H 30 centimeter. Estimate the time required to fill the rest of the tank. So what is this height? And from this height, okay, I believe you know, yeah, this is total 1 meter. Of course, 1 meter minus 0.3, you will have 0.7 meter. Okay, for 0.7 meter, estimate the height. Okay, what is delta T? What is the time required to fill up the rest of the tank? Okay, so the first, when we look at here, we must understand the concepts of conservation of mass, because the extensive property now dealing with the flow of water. All right. So the first, let's assign the control volume. My control volume will be here. Okay. This is my control volume because I want to analyze the fluid flow within the control volume only. As you can see, the control volume is perpendicular to the flow. We have the flow from here. Okay, we have the flow. So this is V1 perpendicular to the cross-sectional area. 2.5 meter per second. All right. So by applying the conservations of mass, all right, using the Reynolds transport theorem, of mass. So we know that when conservation of mass, the mass flow rate for the system is conserved. It is equal to 0. So the change of mass inside the system is equal to 0. But for the control volume, it is d over dt. Remember, we have two components, right? Control volume and control surface. Okay, V and A must be perpendicular. Where do I get this equation? From this one. Okay, this one, where is it? Can you see? 0, that means this is initially from here lah. Okay, this is conservation of mass. Remember, conservation of mass, is conserved. There is no change of mass inside the system over time. So it is equal to 0 and it leads to this equation. D over dt, integral of control volume, rho dV. This is the change of volume inside the control volume plus control surface when there is a flow, inlet and outlet. All right, because we are dealing with area. So just this is the tips. Okay. Flow out of control volume is positive. Flow into control volume, it is negative symbol. Okay. So start with the differentiation d over dt. Okay, d over dt, integral of control volume. Okay, you can see I try to integrate this one with this one. I will get here the volume, right? Okay, differentiation meet with integral, cancel, it will go with rho volume. Okay, volume of what? Volume of this control volume. So what is the volume of this? Okay, definitely area multiply with H. Okay, area of this multiply with the height. We got the volume. So I replace here A H plus, okay, for this part, alright, control surface. Okay, where is it? V1 and V2. So I integrate over area, I will get, okay, the area is pi r squared, right? Because this is pipe. So rho velocity, okay, at point, sorry, velocity, this one, okay. This is velocity 1. Okay, this is plus lah. Okay, let's see. This is plus rho velocity 1. Velocity 1 is into the page. Okay, you can see into the control volume, it is negative. Alright, and then multiply with the area. Area of what? Area of cross-sectional area, which is, okay, diameter is 0.12 meter. So, pi r, which is 0.06 squared. Okay, plus how many of the surface? You have V1, this is control surface at 1, and this is control surface at 2. So rho velocity at 2, you can see velocity 2 is out of the control volume. Move out of control volume, it is positive. So positive here, multiply with the area, which is the same, pi r squared equal to 0. Okay, you can see the density is, for this is, assume density is constant under incompressible. That means the flow have no effect, not affected by the density difference. So this is water. Okay, when you compress, it is hard to see the difference in density. So assume the density is constant. So you can move outside this one. Okay, and then you factorize density, you will get dt AH minus V1 pi 0. Rearrange lah nicely, 0.06 squared pi V1 plus 0.06 squared pi V2 equal to 0. So you move this one to the right, cancel. Okay, between area and the height, which one is constant? Which one is constant, not move and not change over time? Area or height? which parameter constant? A or H? Class.
Area.
Area is constant. The H will vary, right? The height of water.
Yes.
So anything that will vary, we must stick to the DH. So area constant DH over DT. Okay, minus with 0.06 squared pi. Velocity 1 is equal to 2.5 plus 0.06 squared pi. Okay. Velocity 2 is 1.9 equal to 0. So after that, you solve, you will, the area. Okay, the area, I believe you can substitute. So the area of this is pi over 4 multiplied with diameter 0.75 squared. Alright, this is diameter. Okay. So pi over 4, 0.75 squared. So you try to solve this one and substitute to this one. Everything you will get dH over dt equal to 0.0153 meter per second. So the question asks, what estimate the time required to fill the rest of the tank? So the rest of the tank is 0.7, right? The rest of the tank. So dt is equal to dH over 0.0153. The rest of the tank is 0.7 meter over with the rate. Okay, cancel, move up 45.57 second. Okay, any question? Class? Any question? Aiman Mazni, do you have any question? Daniel Haikal, do you have any question? Daniel?
Saya nak kena study balik ada tu.
Oh, lupa dah ke?
Tak, sebab tengah fokus test 1 kan.
Okay. After this, study balik, look at the video recording lah ya. I will send to you the fill up lecture note. Alright. So I hope after this, focus on hydrostatic equation, Bernoulli equation, and buoyancy force. Okay. On your test number 1, please take it seriously to score. Okay, please score at least 15 and above lah, in order to get to pass the fleet 1 and score well. Alright. So for the next lecture, which is the next chapter after this, after integral form, will be taught by Encik Nur Musa and the rest of it. So during a study week, during semester break, 1 week, I'm gonna send the project assignment that's gonna contribute 10 mark from the whole of your coursework. So the project assignment, you need to use the Octave or MATLAB to calculate the problem. Okay, so I think that's all for today. Thank you very much. I end my session with Assalamualaikum. Yes.
Can you send the QR code